So, good morning, good afternoon, good evening for everyone. It's a big pleasure for me to be here. My name is Renan Martorelli. I am a solutions engineer from WSO2. And I am also here with João Emilio, which is a solutions architect here in Elastic. And today we'll be talking about ensuring open banking is secure with Elastic. So giving a brief look into our agenda, we'll basically start talking a little bit about what is open banking and what are the basic requirements we have for open banking for the ones that might not be very familiar with this terminology. Then we're going to look into deep dive into these implementations. So we're going to talk about API management, consent management, and integration as requirements we have for implementing an open banking solution. And then I'm going to pass my word to João, which is going to talk a little bit deeper into the Elastic platform and how we can use Elastic to enhance an open banking solution as a whole. So I won't wait any longer. Let's just start. So talking a little bit about what is open banking. So I've taken a small definition here from InfoMoney. So open banking is a set of rules, technologies that enable sharing of services and customer data between financial institutions through the integration of their respective systems. So here we're talking about rules, technologies, and data. So basically, when you're talking about open banking, we're talking about regulations and legislations that are obliging banks and other types of financial institutions to expose their services, products, and also customer data with consent management, of course. And the idea behind this is to provide all this data using APIs in a manner that these data can be shared between different systems. So it is a conversation, a communication that is happening between systems of these different institutions. And why do we need open banking after all? Why is it so useful? Why is everyone talking about open banking and other open data regulations, right? So basically we have here an idea of how it was before open banking and where we can get with open banking. The main effort, the main advantage of open banking is providing better solutions for the customers. How? Leveraging better competitivity and also innovation in this market. So before we had this scenario where, for example, me as a customer, if I wanted to acquire a financial product, for example, I will need to have a specific bank account in each of these different institutions, just so I could check, compare, and maybe end up acquiring some kind of product. With open banking, we insert a new player inside this ecosystem, which are the TPPs, the third-party providers. These guys are just enablers that can provide, for example, a platform that can aggregate services from different bank institutions in a way that I can, for example, filter and compare in a single screen, in a single platform, many different types of offers. So that enhances competitivity we will have a very clear view on who is offering the best solution because we can just filter it out. And also it will enhance innovation as we can provide things, for example, personalized offers specifically for you combining different products from different institutions. So we can provide a better package of solutions, combining things from many institutions. So these are the biggest advantage we're having with open banking, and we are also seeing this happening inside other industries as well, such as open investment, open insurance is a quite nice movement that is going on right now. So now talking about a little bit about how to implement open banking. So what are the basically kind of requirements you have when you're going to implement open banking? So we're going to talk here about some of the main pillars we have for this. This, of course, doesn't cover everything, but covers the most part, the parts that are not usually covered by a normal bank, which normally he has to buy something or develop this to get this compliance. We're talking about here first about API management. As I said, this main asset that we will be using to trade this information, these communication channels will be our APIs. So being this API is so important, we need to provide better ways to secure them, to have observability, to have governance over them, how many calls are happening, what is the latency of these backends of these APIs. And also it would be very interesting to provide a single platform where the developers, the ones that are going to consume this API, can be there to do everything they need, which we call normally a API dev portal or a marketplace. Then we're going to also talk a little bit about the customer identity and access management capabilities that we need to provide in an open banking solution. And here, talking about mainly two topics, which are strong customer authentication and user consent management. We'll talk a little bit about this later. And also we have integration with core banking systems, which is also a very important part. Also talking about that a little bit later. And covering all these different topics, we also need a security, business, and SecOps analytics solution. And to understand why exactly we need like this part of fraud detection, data analytics, I believe the next slide is going to really help me explain this out. So here we have a view from above of an open banking architecture where we see an API management solution, we see identity and access management solution, and we see an integration solution. That's all the colors, the dots that we saw in the last slide. So this can be a quite complex scenario. Imagine in this case, you have a single API request, just one request that can pass through an API management platform. Maybe this API management platform is also treating this request with an IAM platform for doing some kind of access control or authentication service. And then this request might be passed to an integration solution that will route this request to the specific backend. So imagine that with all this flow, we get an error, we get some kind of problem. Where can we find the exact point where this error occurred? How to deal with all these different variables that a single transaction can have alongside this complex scenario of different types of solutions. So that's why we need to use a robust, an interesting, a powerful engine for security and SecOps, right? So that we can have a clear view of okay, what is happening, where is this errors happening, what's not working right. That's the main part of why we need. And that's where Elastic is going to enter, right? Joe is going to talk a little bit about that. So as I said, mentioning in a little bit more detail some of the requirements you also have for open banking. I've mentioned about the API dev portal and marketplace. This is basically a central place for your developers, not your developers, but developers of other companies, like the ones that are going to consume your APIs, to have a complete package for your APIs in a single place. So a place where they can discover, test, learn about these APIs, check the documentation, manage how is the security they're going to use, what is the subscription plan, if there's some kind of monetization inside this stuff, and basically as a single view. So this makes having a good dev portal really helps with the developer experience, which is something that is very valuable and will also help developers to make better products using your APIs. If you have developers consume your APIs, they will probably create better products with your APIs. So that's nice as well. Then going into the security requirements, we have user consent management. As I mentioned, this is where things get a little bit easy, a little bit ugly, because if you do not implement this right, this is where we can get really troubled legal issues. When we're talking about user consent management, we're talking about having a clear and standard view where customers can see which, how, where, like all the H's and Y's of how their data is being used. So which application is using for which purpose, from what time, just so that they can have a clear view on what is being used. Right, and here we're also talking about having some kind of interface, which normally call a My Account portal, a user portal. You call it how you like it, where these users can see and they can even manage themselves how this data is being used. So you can block, for example, okay, I don't want this application to use this specific data, but this other application, okay, this might be okay. So we need to provide these capabilities as self-service capabilities for our customers to manage it themselves. Then talking about strong customer authentication, which is also an important security requirement. Basically here we're talking about providing better ways to authenticate our customers. We know that financial and banking solutions, they are very sensitive and they are very subject to different types of security threats. So that we need to leverage MFA, TOTP authentication, email, SMS authentication, so that we can have better ways to secure these logging flows. And also in a way that customers themselves can manage how they're going to log in. So you need to give this option to the customer if he wants to use a single factor, 2 factors, 3 factors, 4 factors. Like, this choice must be in his hands after all. And talking about a last requirement, we have banking systems integration. There's a wrong assumption in open banking that, okay, you're going to comply with open banking, we have to rewrite everything. And at the end, open banking is not about rewriting anything. Open banking is actually about finding the right data that you already have and providing this, like the right data at the right time in the right format. So really integrating these different systems, the different pieces of data, so that you can have the exact data format that you need to expose at your public APIs. And we normally say that this needs to be fast because these open banking regulations, they have normally really harsh deadlines. So we need to have a platform that has the same pace, like we can use this in a fast manner. And also flexible and manageable, so that it can be adaptable to different scenarios, because many of these regulations might be susceptible to changes. And as I say, having it in a more manageable way, we can provide a better governance over how these integrations are done. Like, we don't want you to get into detail, okay, this integration was done in one way, this other was in one way, these are all disaggregated. No, we want these integrations in a single place so that we can manage them in a single place as well. And just to summarize everything, there's a really interesting customer case that I would like to talk to you about, which is Société Generale. As I said, I am from WSO2, and this is a customer of ours. SocGen, they used WSO2 open banking platform, which leverages all these parts, as I mentioned, right? So API management, integration, and the identity access management into their open banking platform. And this is a really interesting customer case because they actually had subsidiaries in Hungary, in Germany, and in many African countries. And they used a single technology stack to be compliant with many different open banking regulations. So that really exposes how flexible this platform can be. And if you want to know more also about WSO2 and about the solution, you can just reach out to wso2.com, and we'll be happy to get us with you there. Thank you. And now I'm going to pass my word to João. He's going to keep talking about the open banking is secure with Elastic, right? So he's going to explain how Elastic can help leverage these other parts of the solution, bringing observability and governance all together. Thank you.
Thanks very much, Renan, for the very good introduction about open banking. So I want to start by asking you, why should you consider Elastic as an option to augment your open banking deployment? The first thing that comes to my mind is the number of customers that are already using Elastic solutions to protect their assets. For example, PSU is one of the largest credit union in the United States. By using Elastic, they are now able to reduce the mean time to know about a fraud by 99%. In just about 18 months of this utilization, they are saving $35 million in fraud detection. Another bank is SoftBank. They are using machine learning capabilities of Elastic to detect fraudulent use of credit cards. Now, with the Kibana capabilities, they can also go deeper into the data and explore and get some analytics about the information they have. By detecting also some anomalies, they can start building a story around all the fraud detection mechanisms they provide. And a third customer of ours is Walmart. The first thing that is highlighting here is that they picked us because of the speed. When you're dealing with large amounts of data, it's pretty important for you to have some platform that is fast enough to process this, because you know you have to reprocess and make some iterations. It cannot take days because frauds are happening every day. So they are now meeting compliance requirements. They can go into production much faster, and they are using Elastic to prevent many types of frauds, not just for credit cards and transactions for the customers. Okay, so when I talk about it, it seems too complex. But now I'm going to show you how easy it is for you to start using Elastic and only the out-of-the-box features that we have. For example, let's focus about detecting fraudulent transactions. By using machine learning, supervised learning capabilities of Elastic, you can now go into this data science approach of defining a problem, preparing your data, and transforming and modeling a data source for you to test if a transaction is a fraud. So what I've done here, I've taken this data set from the internet. It calls the PaySim. It regards to a simulation of data based on real data from an African country that is using mobile money services. So this data set looked like this. It's a number of transactions. They are classified by type. They have the amount of and other information. But most important here is that they have classified which of these transactions that happened are frauds. So by using this data set, the first thing I have to do as a data scientist or someone that wants to do fraud detection is to explore this data. So I can just easily upload the CSV file into Data Visualizer. It will give me some insights about this data. For example, if you have number fields, it will give you some statistic about these numbers. What is the minimum, the maximum, and so on. If it is a text, then it can tell you, for example, what categories you have about this information. So we can see now that this data set has 5 types of transactions, and most of them are related to payments. As you can see, there are 43% of these transactions that are payments. So the other thing you can do is to start investigating and going deeper into this data. So I've done here is just a quick filter to show me how many of these transactions are frauds. So by easily using Kibana, I can navigate through this information and get some insights. If I click here on these fields, I can also get some insights as well. Also, we can start building a story around this fraud detection. So using dashboards and visualizations, you can tell other people what you're doing and how you're going to prevent fraud from happening by using Elastic. So here you can see that in this couple of days, we had 300 transactions that are fraudulent, and frauds are only detected as cash outs and transfers and things like that. So what I've done, I've taken this data set and asked Elastic to determine how to detect, I asked Elastic to train this data and tell me if I insert or ingest a new transaction, and Elastic will tell me if that's a fraud or not a fraud. So basically, this data set gave us a overall accuracy over 99%. So by detecting frauds. Let me show you an example by running a Python small demo here. So I've done some simple code, just one to use a not a fraud kind of transaction, and the other one is a document that is considered a transaction because of the behavior it has by transferring all the money from an account to another. So if I run this Python, I can ask Elastic to run a pipeline of information to go to the machine learning job and determine if this new transaction is a fraud or not. So let's wait until the cache warms out, and then there you go. So this first one is not considered a fraud, and the second one is a fraud. So there is also a couple of things you have to do, like determine the probability that is true. So you cannot just go ahead and do stuff, but you can warn people or create actions around this information. Excellent. So going back to another thing that you can do is not just training your data. You can also use Elastic to detect abnormal behavior or transactions in your data set, not only in the past, but also happening real time. By using unsupervised learning, you can use the power of Elastic in your open banking deployment. For example, as Renan mentioned, we need an API management. So we can detect, for example, the abnormal response times, unusual IP addresses connecting to our API management, abnormal payload sizes, because it can be an XML bomb or JSON bomb, by using it to detect in an identity and access management platform, we can detect multiple failed logins and impossible logins from different locations, bottlenecks in integrations, and so on. There's so many opportunities here for you to be ready to go when we are talking about fraud detection and also abnormal behaviors. So if I look into Elastic, when I start working on anomaly detection, this is a kind of thing you can use, a tool that you can use to help you with determining what is going on with your data. So in this case, I've created a machine learning job to detect anomalies in the amount of money that is being transacted. And I split this information by types. So you can see here that the red ones are very risky transactions, and because they have a score higher than 75. If I click in one of these informations, I can go deeper into the details and understand why Elastic thinks this is an anomaly. If I click here, I can get more details, and I can see that this transfer has the amount of money much higher than the usual. It says that the typical is this one, and it's 4 times, the actual number in the transaction is 4 times higher than the typical, which is pretty important for you to understand if this is abnormal. Perhaps you should take a look at this. And it all makes sense when you're looking at the screen, but sometimes you're not, and there are so many other things you have to do. So you have to create some mechanisms to help you with detecting and alerting people. In our Elastic Security solution, we do have this capability. By using alerts, we can leverage a number of pre-built detectors that Elastic Security already have, but we can also build customized ones depending on our data. So things that we can do, for example, it can running through the 30 days of transactions that we took from the data set, we could determine a couple of things, and some things we are detecting, like it looked like a fraud, or no mobile user agents trying to connect to a mobile application API, things like that. So when you detect this type of behavior, sometimes the security analyst, he or she needs to start investigating this information. So by using Elastic Security, you can now create cases against these alerts that are being triggered. So for example, if I want this looks like a fraud kind of transaction to be investigated by my team, I can add this to a new case. And I'm just giving it a name, Elastic on case 1. And I can also create some descriptions and tagging, but also I can, if I had this connector enabled, I could create an incident in Jira, in ServiceNow, or any other tool that is available in our integrations. So it could be, you could be alerting the organization that something is happening and you are investigating this. So let's create this case right here. Case 1. Okay. So now my team also can look at that. If I want to go deeper and see, for example, what is happening in this timeline, I know that in January 11, it's some activity that looks like a fraud happened. So we can use the power of Elastic to start looking at more information. I could even correlate information about the Apache web server right now. So I can look at the Apache events to see if there is something that I also need to attach to my case. And that, let's put this for example, I'm gonna attach this also no mobile user agents detected to my existing case. So now it's just there. I can interact with it, and I can look into my team, and also I can save this timeline. So let me give it a name and say timeline Elastic 1, Elastic on. And I can come back here to if I want to go deeper into this analysis. So there's so many things you can do. These alerts could be sent to a Slack channel, to a Microsoft Teams, or even trigger an API to do something automatic. Okay, so some examples pretty quickly that can help you with securing your open banking deployment. Another requirement that Renan mentioned is auditing and complying with regulations in your countries. When we are talking about auditing, we usually talk about a large retention period, and that also brings the cost of storage. So what you do usually, you store this information into backups, and then when you need them, you can restore the backup and search for the data that you want. But Elastic has this new capability called Searchable Snapshots. What it means is that you can search inside your backups, and these backups can be stored in the frozen tier. The frozen tier is a way for us to store snapshots into very cost-effective storage mechanisms like Amazon S3 or Google Cloud Storage. So this is the kind of things that Elastic can help you with. And last, how you do that quicker, because of the deadlines Renan mentioned are very tight, then you have to put this up to speed very fast. So we are here for you. We have Elastic Cloud to help secure your open banking deployment. It's easy for you to use, just a couple of clicks and you have a cluster already deployed. We take the burden out of your team so they can focus on the business. We take care of the operational hazards, and our clusters are secure from start. You can have security at rest, and you also reduce risk of this data to be leaking outside of your clusters. So we also take care of the personal information sensitive by complying with some specifics like HIPAA, and we have several certifications in the security space. Elastic Cloud is ready for GDPR principles, and for the LATAM customers on the call, we can also comply. We give you the tools to comply with LGPD. So I'm saying goodbye, and we are ending this story right now, but I invite you to go into our website, check more about security, observability, and enterprise search. Try our cloud. We have 14 days for free for you to try us, and plenty of information in our training website for you to learn more about Elastic. So we have this chat available. If you want to make any questions, we are here to answer them. Otherwise, thank you for watching and have a great sessions ahead. Thank you very much.